Today we're going to talk about or have a fairly simple or fairly quick review on how to solve systems of equations using substitution and elimination method. So let's start with substitution. Well, obviously the root word of substitution is substitute. So that's exactly what we're going to try and do. We're going to substitute in one equation for the other. So if I look at an example like number 1, I'm going to rewrite one of these equations, doesn't matter which, and set one of them equal to a variable. So it's pretty easy that I could set this bottom one equal to y. And so we're going to relocate this and substitute it up into this top one. So I'm going to get x minus 1/4. Now instead of y, I'm going to put 4x equals 2. X minus x equals 2. So I get 0 equals 2. Well, we know that when we get a situation like this, and that is a false statement, that tells me that there are no solutions to this system. What does that mean? That means that these two equations are essentially going to be parallel lines. Okay, so let's try it again. Let's see if we can actually come up with a solution this time versus something like no solutions. So as I look at the next one, I have two different equations. One's already set equal to y, so that's easy enough. So let's try that. 1/2 x minus 1/3. And now I'm going to take this, plug it up into here. 3x minus 6 equals 3. So 1/2 x minus 2 equals 3. So here, if I subtract these, I get negative 1/2 x. If I add 2, I get 5. Multiply by negative 2 over 1. So x equals negative 10. Okay, so that's my x coordinate. Now, how do I figure out my y coordinate? Well, I'm just going to plug back in. I'm going to use that bottom one. Y equals 3x minus 6. So I'll do y equals 3 and plug this in. Negative 10 minus 6. So y equals negative 36. And there you go. That's how you do substitution. Simply rewrite one of the equations for one of the variables and then plug it in to the other variable, into the other equation. Okay, so let's try elimination method. Elimination method, what we're going to do, and sometimes this is called the addition or subtraction method. And that is, we're literally going to take this system and treat it like an addition problem. Now, it would be nice if I did this. If I added these together, I'd get 10x minus 7y equals 20. Now, that doesn't really help us a whole lot. So what we're going to do is we're going to try and get one of my variables to cancel. And so I am going to change my y's. So a common multiple, or least common multiple between 2 and 5 is 10. So it would be nice if I make one of them 10y and the other one negative 10y. So I'm going to take the top and multiply it by 5 and the bottom by negative 2. And so I'm going to get a brand new system. It's going to be 35x minus 10y equals 70. And in the bottom I'm going to get negative 6x plus 10y equals negative 12. So now when I add these together, here I'm going to get 29x. My y's go away, and it looks like I'm going to get 58 over there. Divided by 29, x equals 2. So that's my first part. So second part is no different than substitution. We're just going to plug back in. So I'm going to use that second equation. 3 times 2 minus 5y equals 6. Now you could have used the top one if you wanted to. So you get 6 minus 5y equals 6. Subtract 6, I get negative 5y equals 0. So y has to be 0. Okay, so there's my point. Okay, last one. Let's do one that looks like this. Now this one looks a little funny. Look at all those fractions in that one. But don't let that worry you. Okay, we still just simply need to have our variables cancel. So as I look at this, I have a 1/2 x here, and I have an x over 2. Well, those mean essentially the same thing. But what we need them to be is opposite. So I'm going to multiply the top by a negative. So I'm going to get negative 1/2 x minus y over 3 equals positive 1/3. So now, if I'm going to add those together, my x's go away. And if I add 2y minus 1/3 y, I get 1 2/3 y. And negative 6 plus a third is, or negative 7 plus a third is negative 6 2/3. Now that's not really the easiest thing to do in the world right there, so I'm actually going to change everything to mixed numbers. So 5 over 3, and this is negative 20 over 3. So to simplify, multiply by the reciprocal, y equals, because those cancel, and it looks like negative 4. So let's get our other coordinate. Let's see. So I'm going to use the bottom one. I'm going to get x over 2 plus 2 times negative 4 equals negative 7. X over 2 minus 8 equals negative 7. If I add 8, I get x over 2 equals 1. So that means x would have to equal 2. And there you go. There's a pretty simple and straightforward explanation of substitution and elimination method.